And as a structural engineer, many times we learn a lot of things in college and in even practice regarding strength of the building. We use different IS codes. We do the analysis of the building in softwares like ETAP, StatPro. We calculate the loads. We do the steel design. That means AST required. We design the size of the concrete, grade of concrete. So many things we do, analysis, design, and drawings also. But many times what happens? Uh, the stability part, actually there is no as such special code in stability, because stability is very subjective term. Subjective means there may be many options and you need to judge the things actually through your experience and common sense. So stability is most of the times common sense and having lot of options actually, where you need to judge the things. You should observe the things. So observation is very much important in stability. That means there is no exact rule which is given in any book or code. So you might have seen stability, we have learned a little in books and many things. But this part is very, very, we can say artistic, classical and creative. So, but still, whenever I say classical and creative, that means there is no exact rule and there is no exact reference available. But yes, through experience and common sense, we can develop this. So this is very important in structural engineering. Either it is building, water tanks, industrial structures, or any kind of structure, which is a civil engineering structure, bridges or anything. Stability is very much important. And can you tell me what do you understand by the stability or instability? कोई बता सकता है क्या? So we can have an interactive session also, English or Hindi language you can use. And we will just go on, we can say, developing this concept. Okay. Can anybody tell me what do you understand by stability or instability?
Yeah. Equilibrium, sir.
Yeah.
Equilibrium, sir. The structure will be in equilibrium for the stability.
Okay, equilibrium. Now, if you see this structure, do you think this is in equilibrium? Equilibrium है क्या इसका?
Yes, sir. I think
It is
load on the-
equilibrium. Yeah. Is it stable? Do you think so? Is it stable?
yes, sir.
Do you think so? If there is some little lateral load, if I apply, or little vertical load apply, do you think that the structure will be stable?
No, sir.
So can I say if I push this in this direction, say for example, little push, will it be stable now? Or if I just put some additional load here, will it be stable?
Yes, sir.
It's not, it's unstable. Why I'm saying unstable? Visually, it looks stable, I understand. But see, whenever I say visually stable, it is not a stable structure. Okay. For any kind of loading conditions which it may subject to, it should be stable. That is the stability. Okay. If you look at this structure also, it is a equilibrium. Yes, equilibrium. If you see at this moment, it is equilibrium. All. But whenever I say equilibrium, do you know that there are horizontal loads, there are vertical loads, and there are moments, whatever we see. See, for vertical load, yes, equilibrium is there. If I put little horizontal load to this, will it be stable? It will fall down. Yes. Yes or no? If
Yes, sir.
load, it will fall down. Now, can you tell me then what do you understand by stability? Or what is instability? Whatever you can. So in short, I can say that instability is a situation where structure will collapse. Will collapse. Right. See, you know, even though you put little load, it will collapse. If you put additional load here, it will collapse. That means there is something. Yeah, we are not saying that it will deflect. See, deflection is something different. It is not. Deflection word is used within the limits. Structure may deflect, but it should not collapse. If it collapse, then it is unstable structure. Okay, this is, if you look at these two structures, these are unstable structures. Totally, I know that there is a vertical equilibrium here, Fy, but regarding Fx, Even though you apply little load, it will fall down. Or if you apply a moment force, it will fall down, right? So it's an unstable structure. So stability is something related with the collapse. So collapse may be partial collapse or it may be full collapse. Okay, full or partial collapse. Now, see, we know that we design the structures for stability. We design the structures for strength. We design the structures for serviceability. We design the structures for durability. Okay, so generally in structural engineering, we are taking care of these four parameters. There are some other, but we are only discussing regarding the safety aspect, not cost and all. Aesthetic cost is there, but let's keep it aside for the time being. Now, strength, all of you know, strength is something related with the material. Do you know that whatever material we use, either you use the concrete or you use the steel, whatever stresses are coming within the material, either it is a beam or column, and we know that stresses are axial stress, bending stress, shear stress, whatever. So whatever actual stresses are coming in the member due to the loads, they should be less than the permissible stresses. So that we know. And this is something related with the strength. So that is the strength criteria, and there are IS codes available, which will give you the capacity of the concrete in axial tension, axial compression, axial bending tension, bending compression, shear stress, everything. Similarly, for steel structures like ISMB channels like that, we have the actual stress, permissible stress, and there are different codes. Then serviceability is something related with the deflection and crack width. Okay, so whatever deflection are there in the structure, they should be less than the permissible deflection. Durability is something related with the life of the structure. Kindly mute all of you. If I ask you a question, you can unmute. Okay. So serviceability related with the deflection. Now stability. Then what is the stability which is related? So there is IS code available for strength. There is IS code for serviceability and some guidelines given regarding the durability. But as such, stability IS codes are not there. And that's why I call it as a subjective. I call it as a classical. I call it as a common sense. Whenever I say this, then there are no calculations before the decision. Okay, so we take the decision and check the result. Okay, so can you mute? There is some disturbance. Okay, now stability, as I discussed, I will again repeat, is something that structure will not collapse. Okay, now not collapse. That means you should know why structure collapse, why there is a failure in structures. So structure failure may be due to gravity loads. There are many reasons actually. Either due to gravity load, structure may fail, or earthquake lateral loads. Lateral loads. Now actually the reason is not the load mainly, but the reason is something different. Lateral loads may be earthquake or wind. It may fail due to this load. So gravity load is, you know, that it is a vertical downward load in the direction of gravity, and lateral loads are either this direction or left or right, whatever. Horizontal loads, we can say. This is a vertical load, this is a horizontal load. Maybe the reasons, but there are many reasons due to that there is a stability failure or collapse. So collapse. So we can say in general that it is not something related with how much grade of steel you are using, grade of concrete you are using, or how much percentage steel you are putting into the structure. Necessarily not structure will fail. See, many times you may say that there is a less reinforcement in the structure, therefore it fell down. The grade of concrete was not sufficient, it fell down. No, collapse, the reason of the collapse may be actually little different. There is a possibility of failure of strength, but the major part you should focus. So today we are focusing on the major aspect. So don't focus on the smaller aspects in the beginning. in the beginning. So major part you should know. So as a whole or holistic approach, we can say, is important. So we are not here today to discuss on the calculations. Okay, we are not here to discuss on the load, stresses, and everything. It is a totally classical subject, and we will learn or study that in that perspective. Okay. So for example, so now if you look at this structure, then when there is a load, then it will fall down. You know that all the pebbles will go down and fall down. So that means my expected shape is like this, but due to the load, lateral load, it fall down. So we can say the stability is something that expect that your structure should remain like this. For example, for certain loading, there are horizontal and vertical loads. If after the application of horizontal load and vertical load, structure remains in its shape, or there may be little deflection. Small deflections are okay, fine. There is a possibility of small deflection, but it is stable on the loads. But if the structure is something like this, after the load application, let's say your structure fall down like this. Okay, so this is a failure. Okay, this is too much excessive deflections. Excessive deflection is something that is total collapse or partial collapse also. But I can say it is a collapse. It is not a deflection. It is a collapse. See, it fall down. So try to understand that whatever original position is there, if the structure remains in its original position, its shape or position, or I can say form, after the load application with small deflections. Okay, with small deflection is okay. Then this structure is stable. And if it is something like this, excessive deflections or sway, it is a failure. Okay, so this is the overall general, we can say, term or definition of the stability.